In this video, I'm going to go over those recommended practice problems I put at the end of 8.1, Introduction to Predicate Logic. We're going to do the 3 problems on symbolizing with predicates and individual constants, and then 3 problems assessing the properties of relations. So the first problem was page 294, 1a. This was where we had a symbolization key provided for us, right? So we have to use this symbolization key, and we have Bob will graduate, and so will either David or Emily. So we need to do a truth functional paraphrase, right? We need to separate out all of our individual atomic sentences that we're comparing, right? We have Bob and Carol will graduate. We need to break that up. So truth functional paraphrase, the first pass is Bob will graduate and Carol will graduate and David will graduate or Emily will graduate. So there's obviously some more work we need to do here, right? We have 3 different connectives going on. We need to make sure we break that up in a way that captures the meaning. Here I'm saying the main connective is this and, right? We've got Bob and Carol will graduate. That's one conjunction on a unit. And so will either David or Emily. So we have the disjunction on the other side. This conjunction is our main connective. Now we need to input parentheses, right? So we'll have Bob will graduate and Carol will graduate as the first conjunct of that main conjunction. And then the disjunct, David will graduate or Emily will graduate on the other side. So now we need to symbolize that according to our symbolization key, right? We've got GY as Y will graduate. Then we need to, so we're going to use that predicate, and then we need to plug in B for Bob, C for Carol, D for David, and E for Emily into each of these sentences. So our final symbolization is this, right? Bob will graduate, and Carol will graduate, and David will graduate, or Emily will graduate. Next, we have if David joins the army and Emily becomes a longshoreman, she will make more money than he will. So we need to do our truth functional paraphrase. Here I've rephrased these to fit exactly the way that the predicates are phrased, right? If David will join the army and Emily will become a longshoreman, then here we've gotten rid of those pronouns, right? We want only those proper nouns for those individual constants. Then Emily will make more money than David. So again, here we identify our main connective. It's that material conditional, if then. And we have another truth functional connective in the antecedent, right? So we need to add in these parentheses. So we have David will join the army and Emily will become a longshoreman in parentheses as our antecedent. The consequent does not need to be in parentheses because here we just have one predicate sentence. It's a 2-place predicate. So our final symbolization is if David joins the army and Emily becomes a longshoreman, then Emily will make more money than David. And it's important that you have these in this order, right? If you have MDE, then you have David will make more money than Emily, which is not what the original sentence says. So like I mentioned in the original video, the ordering of single terms in a 2-place predicate is really important. The last symbolization problem we have is if David will graduate, they will all graduate. So we know we're going to have an if-then as our main connective, and we have to ask how can we say they will all graduate using this symbolization key, right? We don't have quantifiers yet. Quantifiers will make they will all graduate really easy. But here, if we're saying everyone graduates, that means we have to say Bob will graduate, and Carol will graduate, and David will graduate, and Emily will graduate. It's annoying enough to say it, spacing them all out, specifying them all individually, when our symbolization key says everyone applies to just 4 people. That's why we're introducing quantifiers in the next lesson. It makes it far easier to say these kinds of things. So now we identify our main connective, right? If David will graduate, then this whole second part is our consequent. And in our consequent, we have 3 conjunctions, right? We have 3 ands and 4 sentences. So we have to specify that further, right? We add our parentheses to separate the consequent, and then we need to break the consequent up more. So I'm going to say that the middle and in that consequent is the main connective of the consequent. So now we add 2 more sets of parentheses, right? We have this outermost set at the then and then at the period to specify that this whole thing is the consequent. But then we identify this as the main conjunction and have 2 conjunctions inside. So we have 2 more sets of parentheses. And the symbolization we get looks like this. If David graduates, then Bob will graduate, and Carol will graduate, and David will graduate, and Emily will graduate. And it's important that you do say David will graduate again, right? You can't leave that out, because what this says is they will all graduate, not everyone else will graduate. So you do have to repeat that David will graduate for this to properly capture the meaning. Now let's move on to the assessing relations portion, right? This problem asked you to include some quantified specifications of things. I'm not asking you to do that. I just want you to tell me yes or no for each of the properties. So the first one is NXY. X is a neighbor of Y. So to test for reflexivity, we ask, is every person a neighbor of themselves? The answer is no, this is not reflexive, right? You don't live next door to yourself, you live with yourself. Symmetry, if Bob is a neighbor of Kathy, is Kathy a neighbor of Bob? The answer here is yes, right? If I live next door to, let me make up a name, Jeremy, and then Jeremy lives next door to me. That's how it works. So it's not reflexive, but it is symmetric. And then transitivity, if Bob is a neighbor of Kathy and Kathy is a neighbor of Dave, is Bob a neighbor of Dave? And this one might seem unclear. Some of the questions in the book are less clear than anything I'll give you on the exam. So no, if we read neighbor as living next door, right? If you just mean the person who lives next door to you as a neighbor and not just say being in the same area, then we do read it as not transitive. And I think even if we read it more generally, we can get to the point that your neighbor is someone who lives down the street from you, but they live even further down the street from someone else. This is not a transitive relation. So for this one, the only property it has is symmetry. Next, we have AXY for X admires Y. Reflexive, does everyone admire themselves? The world might be better off if this was more true, I don't know, but it's not the case, right? It's not the case that everyone admires themselves. I think most people probably don't. Next, we have symmetry. Here's my counterexample. If I admire Jennifer Lawrence, does Jennifer Lawrence admire me? Obviously not, right? This is not symmetric. Admiration is not always reciprocated. And transitivity, if Bob admires Sue and Sue admires Joe, does Bob admire Joe? And the answer here is no, right? At least not necessarily. We don't admire all of the people that the people we admire admire, as confusing as that sentence is. So for admiration, right, to admire someone is not, doesn't have any of these properties. It's not reflexive, it's not symmetric, and it's not transitive. Remember, if you can think of even one counterexample to the claim, right? For it to be reflexive, it has to be true in every case that everyone admires themselves. For it to be symmetric, it has to be true in every case that if X admires Y, Y admires X. And for it to be transitive, it has to be true in every case, right? That if someone admires someone else and that person admires a third person, then the first person admires the third person. Last, we have RXY. X is a relative of Y. Reflexive, is everyone a relative of themselves? No, not in the way that we normally think of the word relative, right? Um, People aren't relatives of themselves, they just are themselves. Symmetry, if Joe is a relative of Nick, is Nick a relative of Joe? Yes, right? Being a relative of someone seems to be the type of thing that is symmetric. And transitivity, if Adam is a relative of Belle and Belle is a relative of Chris, is Adam a relative of Chris? And here I'm going to say that depends on how you read it. Because the solution in the textbook says yes, that being a relative of someone is a transitive relation. But I'm inclined to think we can counter-example this fairly easily, right? If, say, Adam is Belle's half-sister, they share a father, and then Belle is also Chris's half-sister, and they only share a sister. Adam and Chris are not related. Adam is not a relative of Chris. So I guess in this one, I'm disagreeing with the textbook, and I would say it's not transitive. Um, but in some ways, this depends on how you conceptualize being a relative of. So this is not the type of example you're going to get on the exam or on assignments that we grade for you. All right, so that's the last problem of the review for this week. We will do more problems in class. You should also be working more problems on your own when you have time, especially these non-starred ones that have the answers in the textbook. I just realized that I left 3A in place for all of these problems. Obviously, this one is 3E. I'm not going to redo this video to change that, so my apologies.